Hello everyone, welcome to my YouTube video. My name is Krishnagand Upadhyay and I am a student of IIPS DAV. In this video, we will discuss about operating system. So let's start. Introduction to operating system. So an operating system is a system software that acts as an interface between the computer hardware and the user. It manages all hardware resources such as the CPU, memory, storage and input-output devices and provides an environment in which application programs can run efficiently and safely. What does an operating system do? The operating system handles all low-level tasks that applications should not have to worry about, such as allocating memory, scheduling which program run on the CPU, managing files on disk, and communicating with devices like keyboards and printers. So, example of operating system: the most commonly used operating systems today are Windows, Mac OS, and Android. Each one of has the same core responsibility but is designed for different types of devices and users. So why is the operating system important? Without an operating system, every application would need to directly control the hardware, which is extremely complex. So the operating system simplifies this by providing standard services so developers can write program without worrying about hardware level details. So process and threads. A process is a program that is currently being executed by the CPU. When you open a browser or a music player, the operating system creates a process for it. A thread is the smallest unit of execution inside a process. A single process can contain multiple threads, all running at the same time and sharing the same memory space. Process key facts. Each process has its own memory space, its own set of resource and its own process control block. A data structure the OS used to store all information about the process, including its state, priority, and register value. So process states, a process moves through five states during the lifetime: new, being created, ready, waiting for CPU, running, executing on CPU, waiting for input, output, or an event, and terminated, finished execution. Thread. A thread within the same process share memory and resources, which makes the communication between them much faster than between separate processes. This is called multi-threading and it greatly improve the performance of modern applications. Process versus thread. A process is a heavyweight, it has its own memory and takes more time to create. A thread is a lightweight, it shares memory with other threads in the same process and is faster to create and switch between. Most modern apps use threads for parallelism. So CPU scheduling is the method by which the operating system decides which process is the ready queue gets to use the CPU next and for how long. Since the CPU can only execute one process at a time, the scheduler must make a smart decision to keep the CPU busy and all processes running fairly and efficiently. So common CPU scheduling algorithm FCFS: first come first serve, process run in the order they arrive, simply but can cause long waits. SJF: shortest job first, the process with the least CPU time runs next, minimize average waiting time. So round robin: each process get a fixed time slice then moves to the back. Fair for all process. Priority: each process is assigned a priority number, higher priority run first. Important task run sooner. Memory management is the operating system functions responsible for managing the computer's primary memory RAM. It keeps track of which part of memory are currently being used and by which process allocates memory to process when they need it, and free memory when a process is done so it can be reused by others. Paging. Paging divides both physical memory and process memory into fixed size blocks called frames and pages. When a process needs memory, the operating system assigns it free frames. Paging eliminates external fragmentation and makes memory allocation much simpler for the OS. Virtual memory is a technique that allows a process to use more memory than the computer physically has. The operating system part of the program on the hard disk in a safe space and bring them into RAM only when needed. They give the illusion of very large memory. Segmentation. Segmentation divides a program into logical sections called segments, such as the code segment, stack segment, and data segment. Unlike paging, segments have variable size and reflect the logical structure of the program, making it easier for programmers to understand. Memory allocation. The operating system allocates memory using strategies like first come, first use, like first fit, or free block large enough. Best fit, use the smallest block that first, and worst fit, use the largest available block. Each strategy has trade-off in speed and memory utilization. Deadlock. A deadlock is a situation where two or more processes are stuck forever, each waiting for a resource that is currently held by another process in the same group. None of them can proceed, none can release their resources, and none can be interrupted, resulting in the system coming to the complete halt for those processes. Four necessary conditions for deadlock. First is mutual exclusion. At least one resource must be held in a non-shareable mode. Only one process can use it at a time. So hold and wait. The process is holding at least one resource and is waiting to acquire additional resource held by other. No preemption. Resource cannot be forcefully taken away from process. They must be released voluntarily. Circular wait. A set of process exists such that each process is waiting for a resource held by the next process in the chain. In the chain. File system. A file system is the method and a data structure that an operating system uses to organize, store, retrieve, and manage data on an storage device such as the hard disk or SSD. It defines how files are named, where they are stored, and how they are accessed, and how space on the disk is managed and allocated. File and directory structure. A file is a named collection of related data stored on disk. Files are organized into directory, also called folders, which can contain other files and subdirectories, forming a hierarchical tree structure. The top of the tree is called the root directory. File attribute. Every file has an attribute, name, human readable label, type, example .txt.mp4, size, how much space it uses, permission, who can read, write, or execute it, and the time steps when it was created, modified, and last accessed. The disk space allocation method, contiguous. Each file occupies a continuous block of disk sectors, fast to access but causes fragmentation over time. Linked. Each file blocks contains a pointer to the next block on a disk. No fragmentation but slow random access. Index. A special indexed block stores pointer to all data blocks of a file, support both sequential and random access efficiently. So thank you for watching this video.